y equals 5 over x plus 2 to the third power. Now the question statement here says to find this derivative without using the quotient rule, but instead rewrite it to use a negative exponent and then use the product and the general power rule to find the derivative. Well, in fact here, that's actually a really good idea because we could start off using the quotient rule, and I will do that in a moment just to compare. But the thing is, you can often rewrite a function to avoid the quotient rule altogether, and if you can, that's a great idea. So if you make this a negative exponent, all you have to do to find its derivative is use the chain rule. And the chain rule says, here we have an inner function of x plus 2, the outer function is the cube, to the negative third power. So we bring our exponent down, multiply it against the 5. So this is negative 15. Leave the inside part alone, subtract 1 from our exponent, then multiply by the derivative of the inside part. And I'm putting this here for emphasis because it's easily forgotten by students unless you make sure you remember every single time to multiply by the derivative of the inside part. Here, it wouldn't matter if you forgot because it's just 1, but generally that's not the case. So my derivative here is negative 15 over x plus 2 to the fourth power. So that's method 1. An alternate method, using the quotient rule, if you're interested in learning how that might work, this is definitely the preferred method because that's a lot simpler. The quotient rule would have you do numerator and then denominator. So the denominator is x plus 2 to the positive third power. It's back over here to the original form. Derivative of 5 is 0. The derivative of this part does require the chain rule, so we go ahead and use the chain rule. Okay. I'll go ahead and emphasize times 1 just for making sure we don't forget it. Then we multiply these two boxes first, so my derivative then has the form 0 minus, then the product of these, so 5 times 3 is 15, x plus 2 to the second power, all over the original denominator squared, which would be x plus 2 to the third power, but then when you square that, you end up with x to the sixth, because x plus 2 cubed squared, that simplifies when you multiply these two exponents. So this is now to the sixth power, which is basically, it is algebraically equivalent to what we have originally over here. It's just there are two additional factors of the x plus 2 in the numerator, which can cancel 2 of those in the denominator, which leaves you the exact same result either way. So it doesn't really matter which way you choose, go whichever way you're comfortable with. But I think that avoiding the quotient rule whenever possible is probably the preferred way.